In this section, we're going to talk about trigonometric identities. So I'm going to give you the basic identities. We'll go through those first, and then we'll do some examples of verifying identities. All right, so we'll start with quotient identities. There's tangent theta is equal to sine theta over cosine theta. And then cotangent theta is equal to cosine theta over sine theta. And those are the quotient identities. The Pythagorean identities, the common one the first one we start with is sine squared theta plus cosine squared theta equals 1. Now, if we take that identity, let me rewrite it over here. I'll put the good ones on the right here. I'm just recopying this. Okay, if I take that identity and I divide everything by sine squared theta, then I'm going to get, it's going to come down here, I'm going to get 1 plus, I go through each term now, 1 plus, that's going to be cotangent squared theta from our quotient identity that we just did, and then cosecant squared theta. We haven't talked about the reciprocal identities yet, but cosecant is 1 over sine, so we can write it that way. Then if I take the original Pythagorean, and we're going to eventually come up with 3 formulas here. We'll divide everything by cosine squared theta. They're all considered Pythagorean identities because they all come from that first formula. And then if I go through each term, I get tangent squared theta plus 1 equals, and then 1 over cosine is secant, so it's going to be secant squared theta. And so these are considered the Pythagorean identities. Just so that you're aware, sometimes they'll use, if you take that top identity and subtract sine squared, you'll get cosine squared theta equals 1 minus sine squared theta. So it's another form of that top one. And also you could do the other way. Sine squared theta equals 1 minus cosine squared theta. They don't usually list those when they have like a page of identities, but those are used quite a bit, so it's handy to be familiar with this stuff. Okay. Even odd identities, so it depends on the function, and I'm just going to start with sine, but sine is an odd identity, and so sine negative theta is equal to negative sine theta. And it seems somewhat intuitive, but it's a really important identity. And similarly with cosecant negative theta, it's going to equal negative cosecant theta. Now cosine is an even function. So cosine negative theta is equal to just cosine theta. So that one's, all of these are helpful, but that one's particularly helpful sometimes because you're able to get rid of the negative sign. If you think about the graphs of what we know about even and odd functions, that's fun to think about too. Okay, and then secant, which is a reciprocal of cosine, secant of negative theta is also even, and so you get, the secant is an even function. So secant of negative theta is secant theta. Okay, and then finally we have tangent, I was putting down here, tangent negative theta. It's an odd identity, so it's equal to negative tangent theta. And then cotangent negative theta, the reciprocal, so it's also an odd identity, is equal to negative cotangent theta. And those are all the even odd identities. So a lot of times you'll use these if you have like, you know, something you're trying to prove and it's sine negative theta. You don't want it to be that. You want to simplify it, and so you'll use these even odd identities. The reciprocal identities, so we've alluded to this previously, but let's just state them. So I'm going to start with, well, I'll just start with sine. sine theta is equal to 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. And tangent theta is equal to 1 over cotangent theta. And then we can do them all the other way. So cosecant theta is equal to 1 over sine theta. So these bottom ones might, you might use them more. I guess they're all used. Secant theta is equal to 1 over cosine theta. You could do a little bit of algebra to prove these. And then cotangent theta is equal to 1 over tangent theta. And those are the reciprocal identities. So we use those quite a bit. A lot of times we don't necessarily want cosecant or secant or cotangent. We want sine, cosine, and tangent. So we'll use the reciprocal. Okay, those then are the basic identities. I'm going to provide a formula page with some of the other identities like the sum formulas and different formulas and things like that. So look for in the pages, in our module, look for the one that says formula pages, and you'll find the copy of the unit circle, the partial fraction setups, and the identity page. And if I think of anything else, I'll put them in there as well. Okay.